The solar power industry value chain consists of the upstream sector, the midstream sector, and the downstream sector. The primary manufacturing process for silicon wafers is to first fill a solidification furnace with polysilicon, then melt, refine, and extract the deposited ingots. These are then cut and separated into the bricks, which are inspected for cracks and inclusions. Next, carrier lifetime and resistance value are measured. Afterwards, the both ends of the bricks are cut, and the corners of the bricks are chamfered. The surfaces are then polished and the bricks are sliced. Next, the final cleaning is performed. After inspecting their external appearance and electrical characteristics, each wafer is graded, and then the completed products are shipped out. TSEC primarily produces and sells crystalline silicon solar cells. This is an estimate of the market share distribution of various solar cells by type. It is anticipated that crystalline silicon solar cells will remain mainstream through 2025. The structure of normal solar cells consists of the joint of P-type semiconductors and N-type semiconductors. In principle, solar cells generate power by converting sunlight energy to electrical energy by using these two different types of semiconductors. In the solar cells, P-type semiconductors and N-type semiconductors are first joined together to form positive and negative electrodes. When sunlight shines on the solar cells, the photon energy excites the electrons in the semiconductor material to produce electron-hole pairs. The electron-hole pairs are subject to the internal electric field formed by the p-n structures in the solar cells and then driven to separate. This causes electrons to move to the negative electrodes, while the holes move to the positive electrodes. Finally, the positive electrodes, the negative electrodes, and the loads in a series are connected by conducting wires to form circuits. As a result, electric currents are generated to supply external loads. The primary step for manufacturing the solar cells is to first etch the surfaces of P-type crystalline silicon wafers using an acidic liquid solution. Then, the texture is formed. The wafers are coated with phosphorus to form an N-type layer through thermal diffusion. The phosphorus glass generated on the surfaces of the wafers during the phosphorus diffusion process is then removed. Next, an anti-reflection layer is formed on the surfaces of the wafers using a PECVD procedure. Then, fingers and bus bars are screen printed onto the front and back surfaces of the wafers to form electrodes. Afterwards, co-firing enables current to flow through the metal paste onto the wafers. The edges of the wafers are then laser isolated and the electrodes are insulated. Finally, the external appearance and electrical characteristics are inspected and each cell is graded. The completed products are then shipped out. The primary production process for solar modules first starts from washing the glasses. Next, put the EVA cover sheets on the glasses and lay up solar cell stringings on the EVA cover sheets. Afterwards, solder solar cell stringings buses. Then, the EVA cover sheets and the back sheets are covered over solar cell stringings. Next comes the laminating and edge trimming stage. This is followed by mounting frames, and then junction boxes are attached and mounted. After the electrical characteristics are inspected and output classification is performed, the completed products are shipped out. TSEC's first rooftop solar power generating systems at the Hsinchu plant began operating on December 26, 2011. The solar power generating systems were built on the east side, west side, and elevator side on the rooftop of the Hsinchu plant. We adopted a grid-connected system with a total area of 1,650 square meters. which has used 680 pieces of solar modules with a 220-watt output, and its annual generating power capacity is 183,469 kilowatts per hour.